Hi everyone, this is Deepak here. I'm going to present our homework for Data 620 Week 3 Part 2. And we are a team of 5: Austin Chan, Justin Herman, Chester Poon, Deepak Mongia, and Michael O'Donnell. So this week we have an assignment to analyze a two-node network. And this time we are analyzing a network of 18 Southern women at 14 social events. So, basically, in 1930s, this data was collected, wherein 18 women were observed over a 9-month period, and 14 informal social events they went to, and basically all the data was collected and put into a data set, which is basically what we are going to use analyze today. So. The main intention behind getting this data collected was to analyze how the friendships arise, or how the friendships determine which events the people go to. These are basically social events, so there is no binding as such. It's mainly because of their friendship and how they know each other and what is the depth of the friendship. So um, we'll first import all the libraries. We have used NetworkX for all the social network analysis. Then we have PyPlot, Matplotlib. Then we have used bipartite algorithms from NetworkX and operator library. Okay, so starting the first step, we are importing the graph as such from the NetworkX. And if you see, it's a bipartite graph. That means there are two types of nodes. One is the women and second is the event names. So there is a function that we've used to check whether it's a bipartite graph or not, and it comes out to be true. So we've seen the number of edges. Um, it's a total number of connections between the women and the events. So as it is a two-node network, an event connects only to women and so on. So we have to find the relationship among the various women, as well as how the events are related to each other. So it's a bipartite graph. We have collected women, which is the top nodes in the women list, and similarly for events. And moving forward, now the first step that we're going to do to analyze this graph is um, we'll take the main nodes as women, and then we'll see the relationship among women based on the events, the number of events that they went to, or the common events that these women went to. So we're using the weighted projected graph here, and we're taking the nodes as women, and it creates a one partite or one node graph, which we are calling as womennet, which will only have the nodes for women, and the edges will be based on how many common events any two women went to. So if you see here, the number of nodes is the number of women that we had in total, and the number of edges is 139. And basically we are plotting um, this this one node graph now, which is a projected graph from the main bipartite graph, based on the common number of events any two women went to. So this is this is the initial graph, which comes out to be, it gives us a very good information. So we've used the thickness or width of the edges based on the commonalities or the weights of the edges. So if you see here, uh, this is the thickest line, the yellow one. That means Theresa Anderson and Evelyn Jefferson were the most connected women, that means they went to most of the biggest number of common events that any two women went to were these ones. And we can see below, we are basically sorting the new graph that we um, built for women. We're sorting the weights, sorting by weights. So now we see Evelyn and Teresa have 7 events in common, followed by these further links which have all 6 in common, and these are shown by all these green lines. So moving forward, we are seeing the centrality, the degree centrality, which means um, how many neighbors each woman has. And if you see, these 7 women have degree centrality as 1. That means they were neighbors with all of the other women based on the number of events they went. So at least when they've all of these women went to at least one such event which had all the women, I mean, and they shared basically the events with all the women. So that's why they have the centrality of 1. So um, we are defining the between centrality as well, uh, which is in the same order exactly which we had the degree centrality, which looks to be true, because between centrality means for any node how many of the shortest possible nodes these women lie on. So these two centralities ratio or the order match. So all in all, we see that it's a very connected graph or connected network for women. Moving forward, the second part is we are analyzing the relationship among events in the same way, but we are taking events as the primary nodes. So we are taking the weights based on the number of common women any two events had. So um, so the number of nodes is 14, which is the number of events. Then we have plotted in the same fashion. Now here E8 and E7, I'm sorry, E8 and E9, this is the thickest or um, the most solid relationship. That means they had the biggest common women going to both the events, which is 9. Here we see after we sorted the number of edges or the weight. So moving forward, similarly we have the degree centrality, and we see that these 4 events have this degree centrality of 1. And moving forward, the between centrality comes exactly in the same ratio as the event centrality, degree centrality for those events. So I mean, broadly speaking, if you see the two graphs, this one and the above one for the women, it's a very much connected graph. So that means most of these women were good friends. That's what we can figure out um, from the above graphs, and it's a very closely knit network. So they share, like as we saw, many of the women share a lot of events, and the women basically who attended most of the events look to be very closely knit, or these were friends. Similarly, for the events, we also see that there are 4 events which have most of the common women attending them. So all in all, we see that it's a very closely knit graph that ends our assignment. Thank you.